G'day there. You're watching the Aussie BIM Guru, and today we're covering a very important lesson in this series on C# for Revit. So in this case, we'll be focusing today on the ways that you can collect elements from your documents. So nearly every add-in command you're going to build is probably in some way going to collect elements at some point. So we can use in this case what's called a filtered element collector to achieve this, a special class in the Revit API, which we're going to look at first. And then we're going to look at another approach that uses an approach that's unique to C#, the System Linq method. In this case, filtered element collectors are a special class that acts a little bit like querying a database. So it's going to take all the elements in the model and progressively filter them down based on conditions you provide. So you can technically just get all the elements in the model using a basic collector, but generally we're going to be providing extra methods onto the collector to more specifically query things that we need. You can declare a filtered element collector using this syntax here, and we will probably just have a quick look at the class itself because it does have a few different constructors that can build the collector in different ways. From there's a lot of methods that we can apply, and we're going to have a look at some of the more common ones that let you specify elements more specifically. So we've got the filtered element class here in the Revit API docs, and we'll see that there is 4 constructors. The most common one we'll use will just provide a document as the argument, and this is the document we're going to get elements from. We can also specify an element ID, in this case the ID of a view, and this will filter down the elements as to whether they're visible in the given view. We can also provide a collection of elements to filter down more progressively. So if we've already got a set of elements and we want to filter these down again, you can use a new filtered element collector and provide these as an I collection or a list in this case, similar to a list of element IDs. And we can also, in this case, also look at link IDs and views as well as a different constructor. But the most common ones you'll generally work with are the document and the document and of view collector. From here, there's a lot of methods that we can apply to a filtered element collector that we're going to have a look at quite soon. We're not going to cover all of them today. There's a lot of things that you can do with filtered element collectors. For example, you can get all things that intersect with bounding boxes. We're not going to go that deep, but we will look at it later in the series. So let's just return to learning more about this really cool class. So what we're doing when we add methods onto our filtered element collector is doing what's called method chaining. This is supported in both Python and also in C#. So a line of code in C# doesn't finish until you tell it to with the semicolon character. So we can keep adding methods after methods, and what's going to happen is that the outcome of that method is then going to be passed on to another method. So in this case, for example, let's say that this object has a method that gets its name, and maybe there's a method that converts that name to uppercase. We can chain those steps together to avoid having to write out multiple steps of code, and also to avoid needlessly assigning things to variables each time we need to do another thing to the next step. So keep this in mind, we will be using this a lot when we deal with collectors. Once we have a filtered element collector, we're going to need to start specifying what we want it to do. A really common method that you'll chain on next will be OfClass. In the context of C#, you will need to say type of and then provide the class name as reads in the Revit API. For example, if you want the wall class, you would say OfClass bracket type of bracket wall close bracket close bracket. And this will get all elements and element types of the given class, if it has any, for the next step of your collector. We can also ask for elements of category. This is a little bit different because it expects a built-in category instead of a class, but built-in categories can sometimes be beneficial because some elements will more broadly belong to classes and you may collect more than you want. For example, the view class also contains things like sheets and view templates and all other things. If you specify the category of views, you will get a more specific subset of elements in this case. So note that in this case, built-in category is what's called an enumerable or enumeration, an enum. In this case, this means there's a fixed range of options available that behind the scenes lines up to an indexer, an integer. So let's just have a quick look at built-in category just so we understand what we're dealing with there, because you will come across this quite often. So if I have a look for built-in category in the API docs, you'll notice it's going to provide an enumeration. And this will work a little bit differently to a class. It doesn't have properties, it doesn't have methods. It itself just supports members. So in this case, you access them like you would access a property, but in this case, these are all going to be explicitly named So for example, if I look for OST rooms, there's a rooms. If I look for OST views, there's a views member. And these are the category enumerations we'll need to specify when we specify our category by built-in category. So in this case, you can see that the syntax we're using here is built-in category.enum. So the enum in this case being the specific option. I'm just going to turn on my pointer highlighter. So we will look at this as an option as well. Once we have these elements of class or category, you'll often want to specify whether they should be elements or element types. So a lot of classes will return a combination of types and instances. For example, I believe that the wall class also returns wall types. I may be mistaken, but I think it does. So you're usually going to want to specify whether you're expecting to collect types or instances of elements as well. It's not always necessary, but it's usually a good habit to get into if you're unsure. It's worth noting that these filters we're using usually fall under two types. The first type is quick filters. So these are things that generally access some data that is available to elements at the surface level in the database. These are things like categories and classes. Very easy to access, very quick to access, because there doesn't have to be a large query involved in accessing this information. So category and class filters are known as quick filters, and they're fairly safe and quick to use. In this case, just note that this is because we're not asking the element for a deeper amount of data. So alternatively, we also have slow filters. Slow filters are still fine to use, but just they will sometimes have noticeable performance impacts. You might notice a slight delay in your code, especially if working with a very large model or a large set of elements. Some examples include the level filter, the parameter filter, and the instance filter. Obviously, these are fantastic filters. They serve very good queries. For example, the family instance filter will get all family instances of a given family type. As well as just the element level filter will try to return all elements belonging to a given level. They're very powerful, but they will be slower. So it is good practice to try to limit down what you're collecting before you use these filters if possible. For example, if you're going to collect all elements in the document and then run a parameter filter, you're going to be working across all the elements in the entire document. But if you first say, just give me elements of a given category, you only have to work across the elements of that category. So it's much faster, much more efficient. So keep that in mind. There is a really good article by Jeremy Tamick where he does explicitly list out what is a slow and what is a quick filter in the Revit API. It's from back in 2015 if you're looking for it on his blog, but he very clearly talks about what is a quick filter. I think it's further down. There we are. So he lists out all the quick filters and all the slow filters as well, which is fantastic. So thank you, Jeremy. There are more complex filters that are harder to construct, and this is where we'll start to look at System Linq methods later, which are much easier to construct. But understand that these are still going to be fairly quick ways of collecting and filtering elements compared to the alternatives. So it is good to know how they work. The most important one, I think, is the WherePasses method, which is going to let you construct a condition through which an element will have to pass in order to remain in the collection of objects or elements. This is an example of just how many steps it takes to construct a WherePasses condition for the value being less than a certain value for a parameter. So we can see the 5 steps involved just to do this. Now I can obviously write more things in place of these variables to reduce the amount of lines of code that I'm working with, but usually it's easier to spell these out quite clearly, I think. So the first step is to actually get an element ID of a given built-in parameter. Built-in parameter again is an enumeration, so you will access the parameter as a member. In this case, from here, we then need to create a parameter value provider object, and that's job is to take part in the final filter to actually provide that parameter as a condition, or as an argument. From there, we have to actually specify what type of rule we're using, and in this case, I'm using a filter numeric less, which means is the value a double and is it less than a given value? And then we more specifically create the filter rule. So in this case, this is a filter double rule. We're working with a double, so we have to specify this. We provide the provider, the rule, and then the value and the tolerance if you're doing an equality check as a float. And finally, we create the element parameter filter using the passes rule. And this is what we provide as the argument to a WherePasses method. it's pretty exhaustive, right? It's pretty annoying to write that out every time you want to do a filter. And luckily there is a way around this, but it's going to be a little bit slower. So it's really good to be aware of how these types of things work. And sometimes you may find you may want to use them if you're dealing with very large data sets or large sets of objects. So we're going to do a quick demonstration before we look at an alternative approach. So in this case, we're looking just at filtered element collectors specifically, and we're going to work in a commands class. We're then going to move on in the second half of this tutorial to look at System Linq and look at extension methods as well. So I'm just going to jump back into our project in C#, and it's worth noting I've done a little bit of cleanup since the last lesson where we built all these types of buttons. So I've renamed some things. I've stopped calling things test, for example. I've got, in this case, a command class for a button, a pull down, and my 3 stacked pull downs, which contain their command classes. I've then also, of course, cleaned up my resources. So in this case, my icons are named to line up with my system. And as well as this, my tooltips have also been modified to line up with the names of the command groups and the commands themselves. So you can always start with my project off GitHub if you prefer, or you can just restructure your project to suit. But I'm just going to be working in the command class that is associated with the push button. So I'm just going to leave this task dialog here. So the first step that we want to do is we want to actually just form a basic collector for all walls in a given model. So I'm just going to say collect all walls, and I'm just going to say var walls. So we're just going to specify that we are happy with the return type of whatever we declare on the right. And I'm going to make a new filtered element collector. I might just zoom in a little bit. And of course, it's prompting us to provide the document, which we previously had in our command class through these 3 variables that come from the command data. I'm now going to hit enter and notice that it indents me. It puts me on a tab, which is great. Now it's actually prompting me to do something we haven't learned yet. This is a System Linq method. We're not going to use it. We're going to keep using the RevitAPI provided methods. So the next step is let's get all elements of class wall. So of class, type of wall. And at this point, we now have the elements of the wall class. We now want to specify that the element is not element type. So we just want the wall instances. Finally, we do need to close this off. So to do this, we can use 2 elements. You can see we can also do 2 element IDs. We can also get the first element, the first ID. There's all types of ways to finish off a collector, but the most common one is 2 elements. At this point, we should now have our walls. So let's actually print the number of walls we have in a string. I'm going to say we have walls.count walls in the model. Before we jump in and test this command, I'm going to create another collector. This time I'm going to go through the built-in category approach, and we're going to create a filter for the WherePasses method. So I'm just going to collect all walls lower than 12 feet. So I'm just going to be using feet in this case. Now I'm in Australia, so I don't use imperial units, but it's important to understand that behind the scenes, Revit will always be working with you in imperial feet internally, which is really annoying. In future lessons, we're going to have a look at how we can build some unit conversion utilities, but in this case, I am just going to work with feet for now. So you win, Uncle Sam. I'm using imperial for a little bit. Okay, so we're going to say var walls filtered. So we're going to, in this case, create walls that are filtered down further. Now I could begin with the IDs of all the walls I've just already collected, but let's start fresh. So I'm going to say, I'm going to get a new filtered element collector, again, of the document. And it sort of knows what I want to do here. I've done this before, but I'm actually going to go of category. This is where you need to specify a built-in category, so you can see it's prompting me towards this. And the really good thing with these, you can actually just search for words no matter where they fall in here. So I can see I can find the OST walls member, and now I've specified the built-in category of walls. Again, we probably want where element is not element type. And now we're going to want to have a WherePasses. And I'm going to be putting an argument in there, and finally specifying to elements. So we actually need to go back and construct our filter. So construct filter. And this is where it's going to become really obvious of how much more beneficial System Linq can be for writing quick code when we get to it, because this is a lot of steps. So the first thing we need to do is get a parameter ID. So I'm going to make a new element ID. And I want to get the ID for the built-in parameter. And in this case, we're looking for the built-in parameter for the height of the wall. So I know from my experience that this is called wall_user_height parameter. Now, how do I know that? There's a few ways you can do this. One is to install the Revit lookup add-in, which lets you inspect the names of these parameters in elements. That is my recommended approach. You can, of course, also go to the Revit API docs and hunt it down. So if I want to go to the built-in parameter class, which is, wow, underneath all those failures. So we can search this page and just luck our way through and see if we can find wall height. Now, this is obviously not a very useful way of getting through here. It's not always going to be obvious. And I know this is more specifically called unconnected height, and there it is, wall user height parameter. So you can try to navigate through the API docs, but it's not as intuitive as using the Revit lookup add-in. Anyway, that is now the ID of this built-in parameter. I now need my provider. So I'm going to say new parameter value provider for that ID. I'm going to create a rule. I'm going to make this a filter numeric less. You can see there's all sorts of evaluative conditions I can build there. And then I need to create the rule to pass. So passes rule. You can call these things whatever you want. It doesn't matter. I want to filter double rule. And we can see we're being asked for 4 things. We're being asked for the provider, the evaluator, the rule value, and the epsilon, which is the tolerance for equality. So in this case, the equality is not really going to matter. So firstly, I'm going to provide the provider and the rule. I can see I'm being sort of prompted through those steps. And we'll say that it's going to be less than 12, so 12 feet, with a tolerance of 0.1, doesn't really matter. And that will be our rule to pass. And finally, we need our parameter filter. So a new element parameter filter, and we're going to pass in the passes rule. And finally, we give that to the WherePasses method. Now, how much work was that? That was an absolute pain in the butt, right? The thing is, this is the way Revit API is intending for you to filter by default. It doesn't mean it's the only way we can do it, but that's it for now. So what I'm also going to do is just print or provide a task dialog telling us that we have walls less than 12 foot in the model, and we now want to put in the walls filtered count. So we're going to jump in Revit quickly, and this will do 2 things. It will collect all the walls, tell us how many walls there are in a task dialog. It will then collect all the walls lower than 12 feet, and then tell us how many of those we have in our model, and then finish. Noting that we're still finishing with a successful result to close out the return type that is expected for our execute method. So I'm just going to jump into debug. I'm just running in Revit 2023 in this case. And we're just going to open up the basic sample project. And I know from experience of this model, there should be around 56 walls, I think, if I remember correctly. And there should be around 40-ish, high 40s, low 50s walls that are less than 12 feet. So we'll hopefully see those numbers or thereabouts when we run our command to know that our collector has worked. So just reminding again, I have associated these to the push button that we added to this. So if I go to and I hit my push button, we have 56 walls in the model. We have 52 walls less than 12 feet in the model. So we can see our 2 filters are working. They're fairly quick. Obviously, this is a very small model with not many walls, but in my experience, you wouldn't expect it to be too much slower than that when you're running in any size project. So the speed of C# is going to really benefit you in those steps. So that's effectively, I guess, one way that we can access elements through collectors. It's just an example, and we're going to look at some other things that we can do now instead. But that's the basics of filtered element collecting. So here's a big one. System Linq is a game changer for accessing and filtering elements in the Revit API, in my opinion. Linq offers link methods that we can use to iterate rapidly across lists of objects. Noting that each step you use a link method in is effectively like looping across your list of objects. So it's going to be a little bit slower. Based on what Jeremy says on his blog, he estimates it might be about twice as fast to use filtered element collectors. And obviously in really large projects or scenarios, that might actually make a pretty big difference. So if you're doing something like collecting all the elements in your entire model and doing something with them, you may want to hesitate to use System Linq methods, but if you've got a controlled or relatively small amount of objects, or just small enough that you know it's not going to be a problem in any scale, they're perfect. And I use them all the time, nearly everywhere. Like I very rarely will use a WherePasses method, just because of the amount of time and pain it takes to set one up. It doesn't mean you shouldn't use them, they probably are good to use. But let's have a look at System Linq, which does come from the system library, so it's not actually from the Revit API, it's a C# specific thing. The first thing we need to recognize is a Lambda function. If you've used Python, you might be relatively familiar with the Lambda function, but in principle, you know how we've created those static classes and we've put little methods in them. A Lambda function is a little bit like one of those that you write on the spot, it gets used up and it's gone. So you can use these to quickly evaluate across an object that you give to the Lambda function to return something more complicated. The syntax is generally an equal sign and then the greater than symbol together, sort of like a little symbolic arrow. And the thing on the left will be the object that is going to be provided to the Lambda function with the variable specified, usually X or I or something like that. And then the function on the right will evaluate the outcome of using that Lambda function for that variable. So we're going to use them a lot. So filtered element collectors versus System Linq, well, it's important to understand that generally once you leave the filtered element collector and start using link methods, you're not going to go back. Generally, you're going to do as much of what you need with a filtered element collector, and the moment you start using link methods, you've sort of pivoted into more traditional lists or iLists of objects that you'll run System Linq methods across. So the common pattern I follow is I establish my new filtered element collector, I then filter by class or category, do anything else I need to do, and then I switch over to System Linq methods. And you'll see what I mean when we work with our example. Probably the most simple and straightforward and useful System Linq method is toList. You're generally going to want to close out your System Linq methods with creating a list out of the objects you've been working across. So rather than dealing with an enumerable, you want to finish with a list because that's going to be very easy to work with. So in this case, you don't actually need to use two elements. You can just say toList, and generally it's going to already have been working with elements, but we're going to do other things before the toList step. So you can finish off a chain of link methods with this one in most cases. Casting is a really important concept that we haven't really touched on too much yet. But when you cast an object in C#, you're effectively changing its type or attempting to change its type. So this is really important with the Revit API because as we learned earlier, inheritance is commonly used. A lot of classes belong to other classes and can be represented by either of those classes. For example, views can be elements, sheets can be elements, a lot of things can be elements. When you work with a filtered element collector, you're using elements by default. So if you want to switch over to, say, sheets, even though you've collected sheets, the filtered element collector won't give you back objects of the sheet type. So you have to actually cast the object to the sheet type when you're ready to deal with it as sheets. Let's say, for example, you want to filter it as a sheet. You're going to have to cast it first. So usually the most common step to establish System Linq is you'll take those elements and you'll cast them into something else if you need to. Distinct is a very useful System Linq method. It, of course, will make sure that there's no duplicate values in a list, and these can be element IDs, strings, numbers, etc. And it's good for a scenario where you're trying to find a range of values, but you know there's going to be double ups in there. For example, maybe you want to get all the possible sheet parameters that are sorting your sheets. You know there's going to be multiple sheets that share the same value. You don't need to see multiple occurrences of them in the final outcome. Maybe you're going to pick them from a list in an interface. You can use distinct to just narrow it down to only those that are unique, so a one-off of each thing. This is where we get to Lambda functions. So Lambda functions are often provided as an argument to link methods. In this case, the select method is the really, really powerful one. This is where System Linq shines. So the select method will actually evaluate a Lambda function and convert all those objects you're working with into the outcome of evaluating that function. What's really important to understand here is that after you've evaluated that function, the type that you continue on with won't just be, the type that we passed into the select method. In this case, it will often be a different type. So if, for example, you're providing some sheets and you're asking for a parameter value in a select evaluation, you're actually going to end up continuing forward with a list of those values, not with a list of those sheets. So you do lose reference to the objects that you passed into the Lambda function. So you may want to work with a separate iteration if you need to keep those objects available for other purposes later. Order by, as it implies, will in this case sort the objects based on the outcome of a Lambda function again. So we pass them in the same way, but the objects still stay the same after they go through the order by method. In this case, they're just organized in a different order based on something that can be sorted. So in this case, this will most commonly be numbers or alphanumerical or strings, and they will be returned onwards. Where is also very useful. This is very similar to WherePasses. But in this case, rather than building up all those variables one after the other, all you have to do is make sure your Lambda function evaluates a true or a false outcome. And in this case, the objects that yield a true outcome will proceed forward. Those that receive a false outcome will not. If you're familiar with visual programming, this is a little bit like a Boolean mask in Dynamo or a dispatch in Grasshopper. So these are very powerful methods. And like we said before, you can chain methods together. So this is an example of collecting and managing a set of sheets. We're going to be looking at this in actually our program quite soon, but we can create a new filtered element collector of class sheet. And then finally, we switch over to System Linq at this point. We cast to sheet. So we make them a view sheet object. And this is because we want to check that the sheets are not placeholders. So we can say where the sheet is not a placeholder is equal to false. And this will only proceed forward with sheets that don't have the placeholder property of true. Finally, we can order them based on their sheet number. And then after that, we can cast them or put them into a list. And we end up with a list of sheets who aren't placeholders sorted by their sheet number. How much easier is that than using the WherePasses method, right? Like it's a big change. Obviously, it's going to be a little bit slower, but in my opinion, I don't notice the difference. We're going to look at also establishing methods and extensions. Instead of just building these in situ in a command, let's build them in a way that we can use again and again and again. So from learning from previous lessons, we know that we can use methods and static classes or extension methods to use these wherever we need them. In this case, we're always starting a filtered element collector from a document, effectively. So let's extend that document. That's how we will begin our filtered element collectors. We're going to create extension methods of the document class, and we're going to provide the document as the this variable or argument, and then we're going to extend that document into what we need using a collector. So we're going to have a look at this quite soon. We're also going to touch on overloading, or in this case polymorphism, but overloading more specifically. An overloaded method means that it has more than one option of how that method can be declared. So let's say we have a method ext_collector, which is going to provide a filtered element collector of a document. Well, in this case, we can also support another version of this method in the same place. It won't clash in name as long as the arguments are different, because C# will understand, oh, this is a different version of that method. And if I've provided the view to that method, it will access a different one that we've declared elsewhere. So we are going to overload our base collector extensions that we build. And they can happily coexist side by side in static classes or in extension methods. So this is going to be a slightly more in-depth demonstration than the last one. We're going to firstly create our document extension class. We're going to create some basic collector methods. So we're going to just create a basic filtered element collector, both without a view and with a view, using an overloaded method approach. We're then going to create a sheet collector extended on the document class and a revision collector extended on the document class with a few arguments that help us control how that outcome is going to be achieved. There's a lot more we can do with System Linq and also with filtered element collectors, but just for the sake of time, we're going to just show some of these techniques in action. So there we go. We finally got to the fun part. So we're just going to jump back into our program, and we're going to begin by creating a extension method because we don't currently have an extension class for document. So I'm going to make a new class document underscore ext. And we can see it's already belonging to the right namespace, which is guru.extension, so your add-in.extensions. And now we want to start declaring some of these methods. Now, if you remember previously, we had to make this a public static class, which we are going to do. And now we're going to be creating some methods that we can use. So to begin with, we're just going to create a basic method that can extend the document class to create a filtered element collector, which we can then do more things with. So we're going to create a public static, and we're going to declare the return type is a filtered element collector. I'm then going to call this ext underscore collector. So we're going to extend the document with this method. I then need to provide the argument of the document using the this keyword, and then that. So we now have an extension that's going to be applied to the document class, and we don't have any other arguments. It's just a basic collector. So we're going to return a new filtered element collector on that document. So this just simplifies the process of establishing a filtered element collector rather than having to declare the document in the scope of the collector itself, when from now on, we're actually just going to extend the document to begin with, even in other methods, just to save a little bit of time. And the reason we're going to do this is because we're also going to create another method in this case. So I'm going to use the same arguments, but I'm now also going to say view. So we now have an extra argument, which in this case will be the only argument available in this overload because document is extended. And I'm just going to say instead that I want the same thing, but view.id. So I'm providing the element ID of that view. So we now have an overloaded method with two possible implementations, and they won't clash. If I create the exact same arrangement of arguments, we're going to end up with a clash because this already exists with the same parameter types. So that's the only sort of catch in how you can and can't overload a method. I can, of course, decorate these methods with summaries. I'll just do one of them as an example. Construct new filtered element collector. So you provide the summary, and then we'd say, what is this? Document. I always say extended, so they understand that it is the thing being extended, and the view to collect elements from. We haven't actually went any further with OfClass, OfCategory, anything like that. At this point, we just have our filtered element collector established, and it's just going to make declaring a collector more straightforward when we work with these. So in the next step, we're just going to actually create a new extension method, and this will return the sheets in the model. So our return type is actually going to be a list of view sheets, and we're going to call this ext underscore get sheets. Again, we're going to extend the document class. Now we're going to actually have some extra variables that we're going to include in this method. So one of the things we might want to do is sort the sheets. By default, the sheets are arranged by their element ID. They're not in a very logical order. So I'm going to create a boolean called sorted. And by default, I'm going to say, maybe we want to say true. Do we just generally want to sort by default? I think we do. Most users wouldn't understand the way elements are sorted in Revit by default. There may be some scenarios where you want the sheets to come in the order they were created rather than the order of something we're going to sort by. In this case, we're going to sort by their sheet number. It's a very logical thing to sort by. And of course, we also want to sometimes include placeholders, but we usually don't. So that's going to be a false argument. So we now have the arguments required to process a collection of sheets. To begin with, we actually want to collect our sheets. So I'm going to say var sheets, and it's prompting me to make a new list of sheets. I don't want that. What I'm going to do is actually take advantage of that collector that we just created as an extension straight away. So at that point, I have a filtered element collector. I'm going to go into a new line and declare OfClass. So we're still using the filtered element collector or the RevitAPI specific arguments. Now we have all the sheets in our model. Now, sheets generally don't really fall under element and element type, so I don't need to say where element is element, where element is not element type. It's not necessary. I can, in this case, just say two elements. Oops. But we could switch over to System Linq at this point. Now I forget if I need 2 elements. I think I might need 2 elements, but we'll check. So I'm going to cast. So I'm going to cast in the triangular brackets, view sheet, not view sheet set. Now I'll just double check if that causes issues if we don't make them elements first. I don't think it matters because at this point we have, we should have a filtered element collector and then we cast them to view sheet. I think that should work. Add to list. And we can check our return type just to make sure this is working. And sure enough, we have a list of sheets. So we've noticed we've used 2 System Linq methods in these steps. At this point, we just have a list of sheets. So I'm just going to also filter out placeholders if desired. And we'll say if we don't want to include placeholders, so I'm reversing that argument, then sheets will get redeclared as sheets, but we're going to also use System Linq again. Now I'm using the where method in this case. So I'm going to call the sheet that we're going to run a Lambda function over S. I'm then going to use my Lambda indicator. And I'm going to say that sheet should not be is placeholder. So what's going to happen here is it's going to evaluate each sheet and it's going to say, is the sheet a placeholder? And then reverse that condition. So the case that we catch here is the sheet is not a placeholder, but we reverse it, which means that when the sheet is not a placeholder, the Lambda function will return true and our non-placeholder sheets will continue forward. Then I can declare to list, and I've now just taken the sheets I already had and redeclared them as a filtered version of themselves. So it's a little bit of a trick there. So notice I didn't have to declare VAR here because sheets already exists. I'm just changing it in this case. Finally, we may want to sort our sheets. So let's say return elements optional sorting. So if sorted, so which will be true if we want to sort, then we're going to return, and we're going to return the sheets, but we're going to order by. So we're actually running a System Linq method across this before we return it. And in this case, like we said, we're going to sort them by their sheet number list. We also need to define what happens when they're not sorted. So else, in this case, we just return sheets. So we've used a combination of filtered element collector, System Linq, and System Linq a couple more times to run through some steps. So we've effectively got a fairly concise function here for collecting sheets in our model. Again, I won't fill in all the information, but if you do 3 dashes, you get all the things you can populate about the function. Let's actually go and implement this in our command. So after we've looked at our walls, I'm going to collect all sheets. So I'll go var sheets equals to, and remember we're going to use an extension method, so doc.ext get sheets. And I don't actually have to specify any arguments here if I don't want placeholders and if I want them to be sorted. I can just close it off like that. If I do want to specify an argument, generally for an optional argument, you'll just want to write out the name of the argument, include placeholders, semicolon, and then the actual argument itself, so true. That's how you can declare them out of order and override the default condition for that variable. But in this case, I don't want placeholders, so that is literally all I have to do in my code when I collect sheets. How easy is that? So if you build all your logic and methods and extensions, you can really simplify down that process quite a lot. Let's go and just make one more extension. In this case, we're going to do it for collecting revisions. So I may just borrow the anatomy of this method, honestly. It's not going to be too different. So I'm going to copy that method and just say get revisions. And we're going to get a list of revisions as our output. We don't need to worry about placeholders because revisions don't have placeholders. And we will sort by default. So we'll collect our revisions. So we're going to change these words as we go. But really the logic is very similar. We get our revisions. In this case, instead of getting the viewSheet class, we get the revision class. And we cast them to revisions. We can get rid of our placeholder sorting logic. And we just work with sorting. So in this case, we return revisions, but we order them, we'll call this R, So in this case, I'm actually just going to sort by the sequence number property of the revision instead. And note, if we don't cast a revision, that property is not available because this is an element, it's not a revision. So that's the importance of casting. It gives you access to things about the object that you wouldn't have otherwise. So now we can see that's now satisfied, and we can just return revisions. And we'll just add description. And that's it. That's how simple it is to create collectors when you work with extension methods. So we come back here, and I can get revisions. And again, we're just going to use an extension method, so get revisions. That's it. That's how simple it is, right? And we can just print the outcomes so that we can see this in the model, make sure it works. So we have, in this case, sheets count. And I'll just copy this as well. And we'll do revisions count. And revision. Piece of cake. So we're just going to run this one more time, make sure it works. But you can see that we can create very functional and friendly code on the surface, especially if you're repeating these over and over again in your functions. And the sheet method is going to be used in so many places. Lots of tools work with sheets. You can imagine having that method available as an extension, rather than writing it out from scratch, and rather than having to use, filter element collector WherePasses methods. It's so much easier, so much faster. So hopefully this sort of shows the benefits and the versatility of C#. We've been able to build things in a lot of different ways here, but this is at least my way that I like to use. So again, we will just run our push button, 56 walls, 52 less than 12 feet, 6 sheets, which is correct, and 1 revision, which is correct. So we can see that our methods are all working as intended. So by the time you see my sample project on GitHub, I will have cleaned this up a little bit. But in principle, you'll be able to effectively just keep building as many of these collectors as you need. Behind the scenes is a document extension method, and you can make this as powerful as you want. So you'll end up with lots of collectors in the end, I imagine. But hopefully this has been a useful sort of exposure to how you can collect elements in Revit. If you're keen to learn more or see how I've implemented more extensions and more collectors, feel free to check out my project on GitHub, gWhiz, where there's a lot of collectors in the document extension. And I'd like to thank you for watching today. If you liked what you saw, feel free to like, comment, share, and subscribe. I know we covered a lot today, so if you did persevere all the way to the end, well done. YouTube generally shows me that people don't watch more than the first 3 minutes of my videos, so I have no idea what people are trying to learn out there, but that's okay. And if you need to reach out to me, feel free to reach out to me through email there, or you can also drop a comment below if you have a question about the video. I look forward to seeing you in future similar videos. Thanks. Take care. Bye.